In this section, we're talking about related rates. Here are your steps. At the bottom, you'll see a little note that if an amount is decreasing, the derivative is negative, and of course the derivative is always a rate. Here are some formulas that you'll apply in this section. Now notice I said apply. This particular part will be given to you on your online test so that you do not have to memorize them. Now you'll have to know which formula goes with which topic, but you will not have to memorize these formulas. Now, we're playing off of the implicit differentiation that we did earlier. So our first problem just gives you a basic function, y equals x squared plus 3. The difference is, in this particular section, I am taking the derivative with respect to t. So since I'm taking the derivative with respect to t, I'll do that on both sides. The derivative of y, and I'll also take the derivative with respect to t of this particular function as well. The derivative with respect to t of y would be 1, and we'll take the derivative of y with respect to t. So it would be 1 dy dt. Now this is just like we did implicit last time, except in the implicit section, when we were taking the derivative, we were taking it with respect to x. So now then, since we're taking the derivative with respect to t, you're going to throw a dy dt anywhere you see a y, and you're going to throw a dx dt anywhere you see an x. So going to this side, we would have 2x dx dt, and of course the derivative of 3 would just be 0. Now look back at the problem. In the problem, it says you have a dy dt, and it says find dy dt. So that means you don't know that particular part. You are given that dx dt is 2 when x is 1. So you're given these values over here. So let's plug them in. So I'll put my plug-in step right here in green. I don't know dy dt, so I'm going to be looking for that. 2, x is given to me as 1, so we'll put a 1 there. Dx dt is given to me as 2, so I'll put a 2 there, and of course I've got my 0. So dy dt would actually equal 4. And that's what we're looking for in this particular example. We started with a smaller one so that we could kind of get the feel for it. Okay, let's try one more of these and then we'll move on along. Okay, so my function, let's say equation, my equation looks like this. We want to take the derivative with respect to t of both sides. So there's the left, and there's the right. Take the derivative of both sides with respect to t. You'll say, now how do you know you were taking it with respect to t? If you look at the problem, it's asking you to find dx dt. So that's how I knew I was taking the derivative here with respect to t. Okay, so let's take this derivative. Using the basic power rule, I would have 6y squared. But remember, throw a dy dt in there. Okay, minus 2x. But remember, throw a dx dt in there. Plus 4 dx dt. And the derivative of negative 10 is 0 because the derivative of a constant is 0. Over here on the right, I'm going to list my given facts. It tells me that dy dt is a negative 3. It tells me that x is a negative 2. It tells me that y is 1. And it asks me to find dx dt. So I don't know what that one is. so when we plug in, we have 6 times y squared dy dt minus 2 times x dx dt. So I don't know what that is, so I'll just keep it as a variable. Plus 4 dx dt, and that equals 0. Okay, so let's clean it up. 1 squared is just 1. So we have 6 times 1 times negative 3. So that's a negative 18 plus 4 dx dt plus 4 dx dt equals 0. So that's negative 18 plus 8 dx dt equals 0. Treat that dx dt just like you would any other variable. Okay, so we can move our 18 over, which would make it positive. So 8 dx dt would equal 18. I ran out of room, so let's go to the side. 8 dx dt equals 18, so we'll divide both sides by 8. And so dx dt would equal, reducing, we would have 9 over 4. And that's my dx dt.